Hi, welcome again. Today we are looking at something different. Earlier we talk about something about landscape and so on. Today I'm going to focus on UVs, like it's fundamental, and I'm trying to show how we can manipulate UVs and get some results like this. For example, let's take a look at one by one. Here I'm trying to show you the clamp mode here. Right now it's not repeating. Now here we center the texture into this piece and this plane, and also we scale that one. And here we we rotate like this, and also now we rotate and scale at the same time. And now we rotate, scale, and also we offset that texture into some place like this. And here you can see now the texture itself is rotating. Also you can see it's circular. Okay, you get the idea. And also now we do tiling. This is a different approach to tiling. I'm not using the default tiling we used to do. Now you can see they're tiled and they also rotate. All right, we can even do scale at this point. It's totally easy to do. Right now you can see we tile, as also they are running at different speeds. So this is a really interesting concept. Based on that, we can do really good things. And this is the basics for creating non-repetitive tiling and all those very interesting stuff. All right, let's get started. All right, first of all, you can download all these example content for free. Just check the description below and you can download this project from GitHub. So let's start with the first one. Right, here I'm gonna talk about the clamp mode. All right, let me select this material. This is the first one. All right, so let me remove this and start from the beginning, so you get you have understanding of what's happening here. All right, I'm gonna put this back to default. I'm gonna delete this, so we don't need it. And I'll go quite slow on the first one, but after that we can go faster. And so we can do this. All right, first thing, this is how we do tiling usual. So let's get a plane over here. All right, quite decent, and nothing much to say. All right, then let's have a look at this texture coordinate nodes. So basically this is our UV coordinates looks like, basically the texture. So here we start with the 0 position here. The X is as a red, so basically X mean the U. All right, and so you can see now this is 0 and this is 1. All right, it's like the same thing for the y-axis, or here we call v-axis UV. All right, so here is 0 1. So this is pretty simple, and that's how it works. And let's say so usually what we try to do is we try to scale our texture using multiple nodes. So this is what happened when we use that. So let me do a multiple node, and let's get the vector 2 constant, and I'm going to put 2 for both axes. All right, so let's preview this. So what's happening here is quite interesting. So it's hard to tell if we put just 2. Let's put some higher value like 20. All right, so basically what's happening is interesting. I think it's totally understandable. So here we have 0, now we have 20, 0, 20. So we basically scale this whole texture. So then when we put this to here, something interesting happening. So I'm gonna remove this previewing. So what happening here is everything. So let's put something like maybe 2, so then we can see. So basically what happening here is it's repeat 2 times on each axis. So then you can see this is 0 and 2. Then why this is happening? So here in the texture it use a wrapping mode. So for example, let's say it's 0 to 2. Actually after the 1, so it will starting again. So here 0 to 1 over here, also 0 to 1 over here. So it's totally happening in this texture sample node, and it's sort of hidden. So that's the automatic behavior, and you can see this on the shared warp thing, and that's the same thing. And the shared is something different. I'm not going to talk about right now, but so this is warping. sorry, wrapping, sorry. And here another mode called clamping. So that's interesting. So when we clamp that, it doesn't do the repetition. So what's happening in the clamping? So here we talk about 0 to 2 here, and after the 1 it will stay 1. So then yeah, you won't see anything after that. So that's the interesting part. So we're gonna use this the clamping mode for the rest of the tutorial, and that's how we can do very interesting things. All right, let's jump back to the second example. All right, here we try to scale our texture inside the middle, in the middle. Okay, all right. So let's open this, and now I'm gonna forget this for a little bit. All right, and then I'm gonna get this texture coordinate node. I think I'm gonna, yeah, all right. And then I'm gonna copy these texture samples as well, or maybe I'll just connect it to this one. All right, and let's get a plane. All right, this is it, and let's try to scale this, the multiple node, and let's I'm gonna put just a single constant because it will apply to both axes, and it's easy for me. All right, and then when I put it over here, you can see now it's scaling at this place. It's not scaling inside the middle, but scaling at here. For example, let's put something like 4. It's scaling down. It's actually so basically what's happening here is this is 0, this is 1, and we use the clamp mode. It doesn't do anything after that. So but this is not what we want. We need to like scale it in the middle. So that's the effect we want. So then how we can do it? So let's see. So I'm going to delete this. I'm going to connect that to this place. All right, here we are doing that. So I can show you here we have the scale parameter, and I'm going to set the default value to something around 0.5. You can see now we are scaling in the middle. So this is very interesting. So here we have the texture coordinate just like the earlier. So here now, in order to do that, we need to do something interesting. For example, let's start previewing this. So you can see now our 0, the origin is located at the top left. So when we scale this, so that's what we did earlier. When we scale texture coordinate like this, so we scale these things from here. So that's why we are trying, we see that effect. So that's why we see the texture is cornered into this place. But so if we can somehow move this coordinate into the middle, so that's where our texture's middle is. So then if we scale from that, scale from there, and then we get the result we want. All right, so that's what we try to do with this translate to the function. It's a custom function. I'm going to show you what is that in a moment. So if we preview this, so basically we just shift. So we know this is these UVs are 0 to 1. So we just put the center origin into the center of this place. So that's what you can see the black here. So that's what's happening here. So now we can simply scale. Right, then we can preview this. So basically it's hard to tell from the UVs, but now we're trying to scale from here. Here this is scale in the inverse side, but just don't worry about that. So we scale from here, and then we have to put this translation. We put the coordinates into this some special place. Now we need to get them back into the original place. All right, that's what we're trying to do with this multiply node. So multiply with the -1. So it's quite easy to see that, right? And then we just connect this one to this UV node, and that's it. So I'm gonna stop previewing this, and that's what we're happening. So let's go to our plane, and let's try to see. We can easily see that by changing the parameters. All right, this one, and I'm gonna open the material instance. Now you can see. So basically I can scale it from here, and let me open these nodes, translate 2D, and what they're doing. It's quite easy, but I want to like create a node in a semantic way. So then when you look at this code for some time later, I understand what's happening, rather than I don't need to read the whole code. Right, translate 2D is quite simple. It's extremely simple. So basically what we're trying to do is we just subtract. So here the range is okay, all right, here the range is 0 to 1, but if I subtract 0.5, it will come to here, and the 0 start here, and the same thing for the y-axis. Just try to understand by from a, like drawing something on the paper, and you get the idea, like just subtracting some value, and you can position the origin back to that place. That's all happening with translate 2D. Right, here just the multiplication, in this case divide. For example, I can show you. So basically I can simply multiply, and from the scale, all right. So basically what's happening here, I'm trying to like scale this by half. So then the earlier the coordinates are 0 to 1, you can see 0 to 1 here, then if we scale from this position, and it will become 0 to 0 to 0 to 5. So okay, so that's what we happen here. So I mean, it's starting from the middle, but usually we try to do the other way down. We can divide this, and then we can get a very interesting, I mean, it's easy to read. So that's what scale 2D does, quite easy. So you, instead of like multiplying, you divide. So then if you need to scale 10 times, you just enter the 10, yeah, and then it will scale that for you. All right, that's the only difference. All right, and we're gonna use this translate node in a very interesting way in the all the other examples. All right, now you get the idea how you can put something into the center and scale it from there. All right, let's go back to the other example. Right, now here we're trying to rotate from the center. So let's see how we did this. All right, let's get the plane. All right, so basically we do the translate, so we get the coordinates into the middle just like earlier. Now we have a special function called rotate 2D, and this is not a built-in function, I just created one. Okay, so basically you put an angle here, and here we put the time node, so then it will, yeah, you continue to push numbers, and it will. I'll explain what's happening in the rotate 2D in a moment, and then you can search online for more later on. So basically we put the coordinates into the middle, and then we rotate that one, and then we get this coordinate back to the original place after that, and then that's easy as is. All right, now you get the idea how we are doing this. And if you go to the rotate 2D function, so this is how it's happening. So here I'm not going to show you the exact way how I got this formula, but it's quite common. So it's called rotation matrix, and just Google it, and it will give you explanation how things are doing that, how you can do that. So this is it, and this is the code that I use. So basically just Google it. So now we know how to rotate this. Here we rotate, and also we try to scale. It's quite simple. So let me open that. So basically we set the coordinates to the center. All right, and then we rotate that, and also after that, rather than translating back to the origin again, I mean the original place coordinates, but now we are trying to scale that as well. For example, here scaling, I can scale 2 times, or I can like half, 0.5. So basically I can do whatever the scale I want, right? So then after that, I'm gonna translate it back to the original place by multiplying this origin. So it's easy as that. So here, so basically we try to rotate that and scale down and move it to a different position, or offset in a different position. And let's try to see how we're doing that. That's number 5. All right, and here it's just like the previous. Here we translate to the 0.5, and that's the middle of this texture. Like we rotate it, scale it, and translate to the original position. And now we are trying to offset into different place. So that's we're doing with the translate at the beginning of these UV coordinates. So initially we offset that to some other place, and then after that only we try to do this step. So that's the only difference here. So let me go to the viewport, so we can easily change these values from there, as you can see here. So let me open this material instance. All right, so this is our place. So basically by default it's 0 0 here, and now here we can 0 to 1 or this UV coordinates, because we haven't done anything there. And now let's say if I put something like this x coordinate to x, u means red, and x it's the same thing, 0.5. You can see I can put it to this place. So but I'd like to put something over here, and so same goes with the y channel. But if you put 0.5, it will go down, right? So because that's why our in Unreal Engine UV coordinates are going down, right? 0 to 1 over here. But if I put 0.5, so I can put it over there. So this is, so it's super simple right now. So this one is rotating like this, and this is exactly the same thing, but I did a little difference. All right, let me open this one. I think that's this one, because I added that later on. Let me close this. All right, so basically this is the previous one. So we translate we translate in the very early the coordinates. But here I'm doing something interesting. So here, rather than accepting the XY coordinates from the material instance, I'm trying to create the positions from inside the material. And here I'm using the sine and cos functionality. So basically, so I'll show you let me open a page and show you the theory behind this. Right, so here I'm trying to show you some math over here, but it's quite simple. And if you don't know about the cosine, just don't worry about it. You can read it from some other place. But the thing we need to think about it, this one. If you know the angle of some vector, all right. In this case, we know the angle. So let's say it's some value. Angle should be, it's a radian. So basically, this could be any value. So continuous value. So you get a circle. Okay. Anyway, so basically, we can think about the x position as cos theta, and the y position as sin theta. So basically theta is a value, if that's a value continuously changing, then we get a rotation. So basically it's a 2 phi. So if you put a 3.14 dd and multiply by twice, and you get a complete circle if you put values like this. Right, then that's the same thing happening. If you're just confused, just Google it, and I'll put this link somewhere in the description. So basically what's happening here is, let me open this. So basically I'm creating the cos and sine and create a simple float 2, and I use that as this one. And I also change the radius. So basically by default it's a unit circle, and it's just 0 to 1, but 0 to 1 is too much in this case. I just change it to 0.4, so you can see clearly. So basically this is the radius, and also I'm trying to change the time. So it's quite fast, and the values are changing quite fast, and then I'm gonna reduce that to 0.3 times. So then we can see. So you can easily control these values and get the result you know. So just like that. So here we just have a circular function, but you can do very interesting things. So let me randomly multiply this one. So let me, rather than doing this one, I'm gonna multiply this 2 times. So then we get a different result, right? Like this. And then if I do this, maybe, so let me multiply this maybe 10 times, maybe. I'm just adding numbers. So you can see you can get really interesting results by looking at, and there are some calculators there that you can put some values and get the function, the graph you want. So basically you can do pretty interesting things with by playing with these values. That's what I want to show you. All right, so let's get back to the other one. So this is quite interesting. If you look at it from here, okay, this is just normal because so basically this is simple tiling, but actually it's not. I'll show you why. So here we are doing clamping. So basically, with the clamp, this our texture doesn't try to like texture sample doesn't try to repeat the textures by itself. So then we need to do something to fix that. So I think in this case it's really interesting to starting from the scratch so you understand what I'm saying. And in the text example we are using the clamp mode, and that's exactly what we need. So I'm going to put it over the emission, and I'm going to connect that into my UVs. All right, so we get this one. So I'm going to start previewing 0 to 1. So that's all we know about. And then I'm going to multiply this one. So here I'm trying to multiply by 20. All right, okay. So then if you preview this, so you basically know we here 0, 20, 0, 20. But our textures can understand only 0 to 1. So here we use the clamp mode. So basically if anything after 1, it will stay 1. So we can't do anything with that. And if we can somehow break this 20 into 0 and 1 ourselves, rather than rely on the text sample node, and that's basically tiling, and it's quite easy to do. We have an option called frac. So basically what's happening is give the fraction. Here if you think about 0 to 1, you have 0.1 blah blah blah, and after the 1 we have 1.1, 1.2, like that. With frac we get the fractions just 0.2 like 1. It is simply ignore the whole number. And if you preview that, now you can see we have 0 to 1, 0 to 1, 0 to 1. In it's not 1, 0 to 0.99 and something like that, but you can see it's happening all over the place, and this is basically tiling. So if we put that into my UVs, actually I need to remove this stop previewing. Yeah, so I think this 20 is too much. Let's put something like 2, and then you can see some artifacts over here. Over these borders you can see like this like white lines, and it's quite annoying. Like if you put into a actual mesh cube, and it's certainly visible, and this is not exactly something we want. Frankly, I'm quite not sure why this is happening, but this is how we can fix that. So here on the MIP map value on the texture sample node, and here we have something called MIP level. So basically we need to send the MIP map levels. I'll show you, I'll explain what are the MIP maps in a moment. So basically if we put that, and we can simply fix the issue. So this is MIP maps. So if you're looking at this object in closer, you get the full resolution so on this texture. But then if you go further, and you really don't need that much of resolution, so you can actually use a low resolution one. So then so it saves our memory, but other than the memory, it gives a very interesting look. For example, if you're looking at this here, we are looking at the full resolution at the earlier. Now you can see some distortion on the texture, and so in order to fix that, we kind of need to blur this one. But if you have like a low quality version, the blurring is automatically there, and we don't need to do that. That's what happening with the MIP maps. When you import a texture into Unreal Engine, it will try to create different copies in different resolutions, and it can automatically change them with the camera distance. Here we just simply remove that, and it fixes our problem, but it's not really good. So then we need to fix that. So it's quite easy. In Unreal Engine we have in the material editor we have a function called compute MIP maps. Compute MIP level, and I can simply put it that to MIP level, and I can get the scale value that we put 2. So we scale these UVs by 2 times in both axes, and I'm going to connect that to this one, and it will give us the original behavior. I think it's quite different, but we get this one. So then if we zoom that, we have a different texture over this place. All right, so then we simply fix that one, and now we try to do tiling like this. Here we do the tiling and also we rotate one by one. Right, let's try to see that. So basically it's this one, 7. And let's get the plane. All right, so basically this is the tiling part we just did earlier. All right, frac, multiply. All right, and here we try to get the this scale values from a material instance, and that's why I do this masking and get only the first 2 values, x, y. Okay, and here we use the texture sample node, clamping MIP level 0, and we try to like create the MIP levels ourselves using this node. All right, and yeah, this is it. So basically after that, just like earlier, now we know 0 to 1 like that. So then we can translate back to 0.5 and we can do like that. And if you think about this, it's could be a little bit confusing. For example, why if we can so how you can actually move this to 0.5 over here, then so there are 4 different things running, so then it's quite different. So in the GPU, all these pixels are processed at once. So then it doesn't matter like you have 4 things here. For the GPU wise, it's 20 things or so, and it's only looking at the numbers. So here we have a 0 to 1 range. Now we get the send it to 0.5. In this case, 0.5 in all these places. Okay, and then we do the rotation and we put it back to the original place. So basically you can do like anything here, like rotate, scale, and before that you can do translate. Yeah, you can do pretty interesting things. All right, this is it for this one, and let's go back to the another one, and it's quite interesting, and it's the very special thing, and that's the key to like creating non-repetitive tiling and so many other things. I'm not going to discuss this right now, but yeah, that's totally possible, and you'll see why. All right, so here this is interesting. Here in the first tile it doesn't move at all, but then it will try to like increase little by different so then if you go far away from this first tile, and the speed is increasing, you can see, and this is how we do it. We have tiling just like earlier. So this is texture sample, MIP maps, and the usual stuff. And here we have rotation. All right, translate, rotate, translate back. So we have seen this earlier as well. The difference is rotation angle. So with the time node, we try to multiply by some value. So how do we get that value? So this value is the speed. In this case, the first one, this 0, we can see, and after that it's getting increase. So how are we going to do that? So let me go back to the first node. Here we use a frac node. So we know with the frac node we can get 0 to 1, like even if we tile 0.999, 0.999, 0.99, like that. We get values like this. Here we have a companion node for that one called flow. So it will give me the whole number. So here 0. So basically flow means the bottom part, and you get the 0 here, and here 1, and here 2, something like that. So you get the idea. So this flow value is quite interesting, and that's pretty interesting. And then what we can do is, so this value is all over the place, not in a single pixel. On all these pixels you get the same value. So basically now we have some sort of number, we can identify a tile, and that's interesting. So here we use a vector length. So basically you can see we have a vector, 2 values, and we can get the length some sort of. All right, if you're not aware of that one. So we get this length and we put it back to the multiply node, and that's how we can get this. Because as we go further and further, this vector length is gonna increase, and then that's how we get these very speedy circular rotation. But likewise, you can put this into a noise function. So let's say in a noise function, you have some sort of seed or something, and then you can get the similar value for each and these tiles, and then based on that noise function, you can rotate that one. So basically, you can rotate each and every tile in a different values. So yeah, rather than this uniform speed, something like that. So that's why this trick is really interesting, how we can do that. All right. So I think we cover all these things, and I think you have a clear understanding of how UVs are working. If that's not, try to get this project and try to play with yourself and understand what's happening. And if you really master this, and I think you could do really, really interesting things. Right. Let me know how this tutorial looks like. I'm planning to do something similar like this in the future. If you really like it, I can do that. If you don't like this, just tell me why you don't like it, and then I can improve a lot from this. All right. See you soon with something interesting. Bye.